we'll get started with today's webinar. Um, and it has been cryptically titled as GraphQL Federation equals a function of subgraphs. Um, this is what we hope the first of the many conversations we will have about GraphQL Federation and how the quality and the speed at which you can achieve GraphQL Federation is going to be impacted significantly by the quality and the speed of your subgraphs. Lots of different vectors in terms of understanding GraphQL Federation, but today we are going to focus primarily on the speed with which you can go to production, focus on your features, and get that feedback loop with your customers going by building subgraphs very quickly. And with that, we'll kind of hop into our first kind of architecture diagram to understand what GraphQL Federation is. I'm sure most of the participants today know that at its core, GraphQL Federation is kind of a unification, not just unification, but also like a relationship layer over subgraphs. At its core, it's simply just that you have a couple of or a bunch of GraphQL subgraphs, you federate over them, and you're able to present a unified semantic graph to your applications, which makes life easy for the application developers to fetch data without duplication of effort and so on. We understand this. There are two ways of kind of building subgraphs. You can have a subgraph built directly over your data source. This could be databases, REST APIs, whether internal or external third-party ones. Or you could have existing microservices over your data sources, and you're building the subgraph layer on top of that. Both are pretty legitimate architectures to follow. A lot of factors here that we will not get into in today's webinar around who owns the microservice, who owns the data source, is the subgraph being authored at a central layer or individual teams and so on. We'll not get into that in today's webinar, but hopefully in a future iteration of this webinar series, we will touch upon those because those are important aspects to talk about, especially when we talk about aggregated architectures like GraphQL Federation. With this premise, David, I invite you to talk about your experience building subgraphs and federating over them.
Absolutely. Thanks, Sandeep. Hey, everyone. As Sandeep mentioned, I'm an architect here at Hasura, but in my career, I've mostly been a backend engineer in many different settings, in enterprise settings. There once was a time, and there still is, where we've been building microservices. Microservices begat GraphQL. I've worked on projects where we've implemented GraphQL and worked our way towards, some sort of federation or supergraph or one graph or whatever you want to call it. And coming to Hasura has been an enriching experience because we've been able to get to a place where we can get to the subgraph development, which, as Sandeep mentioned, is sort of the cornerstone or one of the foundations of getting to this supergraph or one graph or federated architecture. We can build those subgraphs and deploy them so much more quickly with tools like Hasura. And that's really, that's sort of, it's not very profound, but it shouldn't be. That's one of the key takeaways of this webinar and this presentation is how quickly and how thoroughly one can get to production-ready, enterprise-grade subgraphs with Hasura or tools like Hasura, which can then be enrolled in a supergraph or a one graph or a federated graph. And we'll demo some very briefly some of the way that this is done in Hasura, or one of the ways that this could be done in Hasura. Go ahead, Sandeep.
One thing I'd like to mention is many moons ago, David was somebody who was part of the community as a user of Hasura before joining Hasura. So he's kind of gone through this journey of trying to DIY GraphQL subgraphs and went through that experience, understands the intricacies of that journey, and then kind of tried to use Hasura, started to use Hasura, took it to production, and then joined Hasura. So it'll be kind of interesting to get the insights of that journey.
And I can say some things that would anticipate the coming slides, but I'm looking at this, and I think Sandeep's got some things to say about some concerns, some federation concerns and subgraph concerns, but I can elaborate as well.
Please do. I think this is more a distillation
Yeah.
of
So
what you were
yeah.
going
So
to.
you know, Sandeep, you know this. There once was a time where I tried to build something like Hasura a long time back, and part of the reason is, as a backend engineer in for both microservices, REST-based microservices, and GraphQL, you find yourself in the position of writing a lot of code. I'm a software engineer, and I've written a lot of code, and I don't like it, and I don't want to do it anymore. So, if I can find some way if we can find some way to get to market much more quickly, um, by not having to repeat ourselves quite so often, that's worthwhile. And so one of the things that you and we've done at Hasura is to clarify what are the different activities that we're performing in the code that we're writing? What are the different concerns, the functional concerns and the non-functional concerns, and which parts are the same every time, and which parts are differentiated and which parts are undifferentiated. So undifferentiated, what might be some of those non-functional concerns, maybe performance, caching, security, the simple fact of marshaling data between some data source backend and an API. Often these are things that need not be repeated every single time. Differentiated pieces of the code that we then write might be business logic, validation rules. So by clarifying that, by putting us in a position of we're still writing code, make no mistake, we're still writing code, but we're writing just the code that we need. We're able to get to market much more quickly.
I think the central position of this webinar, and I guess Hasura as a product, right, is that if you really analyze the kind of effort that you're putting into, going through your GraphQL journey, you're essentially spending a lot of time in the subgraph stages and very little time in the federation stages, right? Like once you have the subgraphs, I think across different kinds of products, the way to federate it is mostly declarative, right? You end up getting rate limited by your subgraphs when it comes to kind of building out your federation architecture. And I think that's the central position of this webinar. And that's what we'll kind of see in the demo as well. And I guess what we're trying to say is that with Hasura, you get to attack the problem where it needs attention, right? Like Hasura kind of simplifies the process of building a subgraph by kind of removing the boilerplate stuff that you need to. And think back to the non-differentiated code that we were referencing in the previous slide. That is the portion that Hasura kind of tries to simplify. And even the part that is differentiated, some of it can be handled with declarative configuration, for example, the Hasura authorization subsystem. David, any thoughts on this before we head to the demo?
Absolutely. As Sandeep mentioned, even the differentiated pieces, so broadly speaking, one category of differentiated activity is business logic, but we can further subdivide business logic often into a few categories. Some of them are right here on the screen that you have in your slide. There's input validation. There is authorization. Input validation and authorization are two common categories for business logic that we're writing. By recognizing that, then Hasura is able to offer affordances for doing this in a much more streamlined and uniform fashion. And in fact, in the case of authorization, it can even be done in a declarative fashion without even writing any code. So absolutely.
Yeah, and I think this is a kind of the story that we see playing out multiple times. So David and I, like I mentioned, we kind of work with our users and customers, mostly with the engineering teams. And I think at the end of our
yeah,
go on.
One other observation, and folks, we appreciate your patience. We'll get to the demo shortly. It will be a quick demo. It should be. That's the whole point. Where we are stipulating that you can get to a subgraph quickly. So this will be a quick demo, and we'll get to it soon. But Sandeep, one of my experiences has been, GraphQL came along and it makes a promise. It makes a promise to data consumers that you can access and consume data in a uniform, machine readable way that allows you to get exactly the data that you need, no more and no less. In the offering is for consumers. It makes life a little bit easier. But it imposes a burden on sort of backend developers. Someone has to develop these GraphQL APIs. GraphQL APIs don't necessarily come for free, and supporting the flexibility that GraphQL offers can sometimes be an arduous task. And so sometimes in my experience in the past, GraphQL backends can be developed which are almost GraphQL in name only, right? For the GraphQL aficionados on the call, you might have a shallow GraphQL schema with a large number of top-level fields, which, if you pay close attention, are little more than glorified REST endpoints. And there's little flexibility in what can be done. And to use this GraphQL API requires a great deal of orchestration on the front end. And that's the easy way to get to a GraphQL backend when you're writing code. Getting to the bona fide GraphQL backend that has all of the power and flexibility that GraphQL offers with code, again, it can be an arduous task. And again, that's where something like Hasura comes in.
Good. David, it's time for a demo.
Yeah, why
Do you
not?
want to talk about what, and again, in the
Yep.
spirit of this continued conversation, do you want to talk about what are we going to demonstrate today and what are we lining up for subsequent webinars?
Absolutely. So the demo, really, this demo is, for folks who are familiar with Hasura, this will be bog standard Hasura. It is building a GraphQL APIs. In the context of this webinar, they are GraphQL subgraphs with Hasura, and then illustrating one way to bring these together into a supergraph or a one graph or a federated schema. So I will start sharing my screen and then also talk about what we will be showing. So what I'm demoing here today will be two GraphQL subgraphs using Hasura for a rudimentary toy retail online retail application. It's a grocery store application. There will be one graph for a catalog of products, and then there will be another graph that supports the ordering of those products. We can do this, and I've done this before in a number of different settings. We could use Hasura Cloud. For folks familiar with our cloud offering, we could do it right in Hasura Cloud. That's a real quick and easy way to do it. Just to change things up a little bit, I thought I would do it locally. You can, with Hasura, you can also deploy locally. In this case, we're using Docker Compose, but those are just details. Database launched locally. One of the virtues of this, and I'll share the link to this. This is all in a GitHub repository. If folks really want to get to this, you can grab these files and run this yourself. So I'm in this directory, Hasura webinar 2024. I guess that's when we are. I guess that's what this is. There's not much here. There's a there's a Docker Compose file, and you don't even really have to know what Docker Compose is. But the principle is very, very simple. We're just running a couple services, a couple Docker services. We have a database, Postgres. We need it. Hasura builds GraphQL APIs over data sources. This is sidebar. This idea of providing automatically generated APIs over data sources it's an old one. It's maybe even an obvious one. There are lots of folks doing this, lots of ways to go about this. Hasura is one way. What I would say is, what's nice about Hasura is, to do this in a real, in a production grade setting. I keep using this word. It's an arduous task. So Hasura is batteries included. It gives you GraphQL services with a lot of these non-functional concerns included. And that includes supporting a wide variety of data sources. So in this case, just for simplicity, I'm using a Postgres database, but Hasura supports Microsoft SQL Server and Oracle and Snowflake and ClickHouse and MongoDB. We support many different data sources. But in this case, just for simplicity, we have a Postgres database. I'm going to use, Sandeep, I'm going to use you as my as my foil or my rubber duck. Does that make sense, Sandeep?
Absolutely. It does. It does. Can't
Sandeep
wait
is
for more.
Sandeep is my boss, and this is the first time I've ever called my boss a rubber duck. Yeah. But
It's
I know
called me
you don't like
words, but not get into that now.
it. And then there are two instances of Hasura, or as we like to call it, GraphQL Engine. GraphQL Engine 1 and GraphQL Engine 2. Why are there two? Because we have two subgraphs. We're trying to show some federation. It so happens for this demo that they're both pointing to the same database, but in a production setting, they would probably be microservices that own their own data. So those are some details. I do have a data model in here. If we look in initdb.postgres, there's the usual database, some DDL to create some tables for accounts and products. And we insert some sample data. We don't really need to dwell on that, but these things will be set up automatically for us. So let's just run this. And by running it, Docker compose up, which I just do in my editor. So this will launch, again, this is launching these services in Docker Compose. And while this is happening, why don't we check to see what's happening in the chat? Hey, folks. Hey,
I can take that. Somebody has a question about whether Hasura supports Redis as the data source. The short answer to your question is yes, but not yet. The long-winded answer to that is you need to build a connector. So Hasura has kind of built an interface to support any and all data sources. So if anybody needs to support a data source, you just need to write a connector. We have a long roadmap of connectors to be built for the community. If you want Redis as a data source, you can go to the website and express your interest in Redis as a data source, and we can kind of use that as a signal to bump it up in the priority list. But the specification of the interface is open source as well. So if you're interested, we'd be happy to collaborate with you, or you can write the connector yourself. So hope
that's right.
Clarifies.
All right. Now I am in the process of trying to close this chat window. So 1 second.
David, while you're doing this, I would like to add one more point to it. So Hasura does, one of the non-functional concerns that David was talking about earlier is caching. So if you're using something like Postgres or Snowflake, let's say, and you want to cache some data and read from this, let's say, Redis cache, you can do that out of the box. So Hasura does a query response cache, which is built on top of Redis. Right? You can configure an environment variable with a connection string to Redis, and Hasura can read data off of it. So that's one way in which Hasura already reads from Redis, but maybe not quite in the way that you were expecting.
Exactly. Thanks, Sandeep. So what you're seeing here, this is a SQL client window connected to this database. So all of these services are up. So the Postgres database is up. 2 Hasura instances are up and running. And we just see that, there are some tables that have been added. We have an account table, an order table, order detail, products and regions. We have data in these places. So let's head over to Hasura. I've claimed that we have a couple Hasura instances running. So let's take a look at those. Let's go back to this Docker Compose file real quick. So we see that Hasura, these 2 instances of Hasura are they're running locally on my laptop on 2 ports, HDE port 1 and HDE port 2. What are those? Well, those are brought in from an .env file. Looks like they're 8081 and 8082. So let's take a look at those 2 locations. Localhost 8081. So what's happening here?
I'm guessing these are the 2 Hasura subgraphs that you're building?
They are. But for folks who might be unfamiliar with this, Hasura, again, it's it offers a number of services. One, it provides this GraphQL API, but it also provides an authoring environment for authoring the metadata, which is used to curate the graphs that you're building in Hasura. And what we're seeing here is the graphical user interface, the authoring environment. We call it console, which is or can be provided by Hasura. Of course, in a production setting, you might turn this off, but in a development setting, this is available. And so if you just go to the root of where Hasura is deployed, automatically it will provide Hasura console, which is this authoring environment. So here's one for 8081. In another tab, we'll open 8082. These are our two instances of Hasura. There's nothing in them. Nothing in the, we don't have a graph yet, because I want to show how quickly and easily, one of the objectives of this is to show how quickly and how easily one can build graphs with Hasura. We know that we are connecting to a Postgres database. So on this data tab, I've chosen to connect to a database. Give it some name. We just say default. And you can pass in there are a variety of ways of doing this. You can pass it in the database connection string directly. In this case, with the Docker Compose file, I've set up an environment variable db_URL. And what will happen is Hasura will connect to this database. It will recognize that it is Postgres. If it were Microsoft SQL Server, it would recognize that. It will introspect the database's catalog and show us what is available, right? So we have these tables and some views and some functions are available. So one of the operations that as a GraphQL developer you'll perform with Hasura is, in lieu of writing code, you just track tables. Tracking a table means we present this as part of our GraphQL API. So we will track the account table, the order table. Hang on a second. Order. So orders belong to accounts, have orders. An order encapsulates some number of line items or order details, and orders occur within a sales region, let's say. And what this means is simply by tracking these tables, if we head over to this API Explorer tab, on the left, we see that already we have started to develop some top-level fields for these tables. We have an account table, we have an order table, but it's very shallow. It's not very graph-oriented. We can fix that. If we go back to the data tab, we can, in addition to tracking tables, Hasura will also introspect relationships that exist within the database, in this case, foreign key relationships, and it will suggest that we develop relationships in our graph. Now, you can do this manually, but in this case, it makes it very easy to just track all of these relationships, which means establish within Hasura these connections between these types. So having done that, we head back over to this API tab that we're using to evaluate the work that we're doing. We now see that our API is becoming more graph-like. Under account, we now have orders and order details. That's pretty close to what we want, but that's just one graph. Now, part of the goal of this is to show something like federation. So let's head over to the other graph, subgraph that we have, which is on port 8082. Let's hide this helpful panel right now. And we'll perform a similar activity, but for a different portion of the data model. We will imagine that we have another database which has our product catalog. Again, we will connect, we will give it the database name, call it default, could be anything. Again, db_URL is the environment variable that I happen to set up. Show you that really quickly. If we go over to our Docker Compose file, we see that we've told each of these GraphQL instances, we've told it that it has some environment variables, one of which is db_URL. So that's how that comes in. So we'll establish our connection. Now again, one of these subgraphs represents sort of the fulfillment activities, accounts, orders, order details, and the other just represents a data catalog. So within here, since we're actually connecting to the same underlying database, we will see the same tables, but the only one that we really want to track right now is product. We'll say, let's track the product. So this graph this subgraph. Remember, we're talking about subgraphs. This only presents just the products. Let's take a peek. Let's see what we have. Let's just get 10 products. Zucchini, sugar, sour cream. Looks like it's a grocery store. Okay, great. So now we have these two. We have these two subgraphs, and we might want to bring them together into a some kind of supergraph. Sandeep, is it clear what we've done so far, or where we're going?
I think so. Yeah.
All right.
Do you have two subgraphs created and
Great. So bringing these together into one supergraph or one graph or federated graph, we have a few options for doing this. A federation is one. Apollo federation is one. There are other products on the market. In this case, I'll be using something from our friends at the Guild, which is called GraphQL Mesh. Real quick, we can take a peek at this. GraphQL Mesh, which, Sandeep, one of the two observations. GraphQL is, you and I know this, it's a general purpose query language. It is similar enough to SQL, right? So SQL has tables, which are collections of attributes, and tables can relate to each other. GraphQL has types, which are collections of attributes, and types can relate to each other. There's broad similarity between GraphQL and SQL, which is, it invites transformation. And you and I both know that one of the things that Hasura does, the way that it gets there with, say, a SQL database, is by translating GraphQL queries into SQL queries. So in some ways, GraphQL is similar to SQL, but one of the nicer properties of GraphQL is that it's much more regular. You and I both know that SQL has so many different variants, so many different dialects, but GraphQL is highly regular, which makes it a little easier for it to be machine readable. And so as a consequence, there's a rich ecosystem of tooling built up around GraphQL that all interoperates. And that's one of the reasons why there can be something like GraphQL Mesh, which offers a variety of services over GraphQL data sources. You can transform GraphQL APIs. And one of the things that GraphQL Mesh will do is it can bring together graphs into a supergraph. Again, Apollo Federation is one way to do this. Hasura remote schema is another way to do this. In this case, just for fun, we're going to do it with GraphQL Mesh. So with GraphQL Mesh, it's a runtime like these other applications. It's a server I have installed already. Many of these tools are like Hasura is. It's configured declaratively. There's a YAML file. You specify, well, what are my sources? What are my data sources? Well, I have two data sources. These are my subgraphs. I have a catalog subgraph. There it is, localhost 8081. And I have a fulfillment subgraph, localhost 8082. And then we are trying to add some additional configuration wisdom to this to try to bring these together. So let's head over to our, yeah, go ahead.
David, so that's, I'm guessing catalog will translate to products and fulfillment will be something related to orders because obviously they are related, and you're going to try and get that relationship going, right?
That's right. So the idea is, hey, I have in one subgraph, I'm only tracking one table, which is products. That's my catalog. It's just a catalog of all of my products. And then fulfillment has accounts, orders, order details, and those things. So having done that, we can just say GraphQL, or sorry, Mesh Dev. In this case, we're launching GraphQL Mesh in development mode, using that configuration. And in dev mode, GraphQL Mesh pops up its own Explorer. This is much like a console that we just saw for Hasura, but this is the playground environment for GraphQL Mesh. So we can start writing queries for, we do accounts. There we go. Accounts, limit. Let's just get 10 accounts. We can get the name of the account. We can get their orders. For the orders, we can get, let's say, well, what's the status of the order? And we are starting to get some data. And looks like we're not afraid of the demo gods. Order ID, units. And oh, there we go. Oh, that's what it is. So these data are randomly generated. So, some of these accounts, they don't have any orders, but some of them do. There's orders, order details. What about products? Can we get to products? Products. Let's just get same thing. Let's get 10 products. Name and price. So there we go. We have a unified graph over both of these sets of data. There's only a little bit more that I want to show, but why don't we take a pause there, Sandeep? Do you have any questions or comments? What do you think of this?
David, do you mind scrolling down on the response of this
Yeah.
query? Did you also show the fulfillment, or is this just the catalog?
This is the catalog. So what we'll do is let's do this. This, like many of these tools do, this has a history. Let's go back to a previous query. Let's do this one. So this is the fulfillment query with account, name, orders, status, order details. Let's run this and close this. All right, here we go. And now one of the things, folks, where I was trying to get to in the demo, and I'll make sure this is available for, it's a little bit of a work in progress. I'll make sure that this is available when I, well, I'll provide the GitHub repo, but the full federation will be available. What I want to get to is for order details, I should be able to bring in product data from this related subgraph, right? So we've ordered some products, but what are the products that are associated with this order? Name and price. And in principle, this is where
this is going to come. So this is going to come next, but what you've done so far is kind of bring up a union of the individual schemas. Is that where things
That's right?
Okay, got it.
And where we want to get to is a hierarchical representation where we're getting account, order, and order details data from one subgraph, but then getting the related product data from another subgraph. There's a little bit of yeah. So there's in order to teach GraphQL mesh in order to configure it in precisely the right way, there's a few details that I was just working on this morning that I have to get these exactly right. So we're running into again, it's a work in progress. It's not a big deal. But you would perform.
I think what I'd love to see, I guess, in again, once we start talking about GraphQL Federation in more detail, is to kind of see this federation done in GraphQL Mesh, in Apollo router, maybe, in Hasura perhaps, and just look at how compare and contrast these different approaches. But again, kind of come back to the same point about subgraphs, right? Like do whatever you want on the federation side of things. Like you said, it's 20% of the effort, this demo notwithstanding, due to time constraints. 20% of the effort is what it'll take to get the federation stuff going. But if you're going to go back to the subgraph that David generated, there's a whole bunch of things that we haven't gone into to avoid repetition. There's a lot of literature that we've put out already in terms of authorization, in terms of caching, and all of those other non-differentiated or non-functional concerns that David was referring to earlier on. But suffice it to say, there's a very clear and quick path to a production-ready API. And again, that's pretty much the end state that a lot of our users and customers kind of try to go for. And with that, we can revisit the demo again. But David, maybe time to answer a couple of questions in chat.
Absolutely. Yep. Let's go for it.
I think Paris has a question about, hey, what if you're stuck with a database schema that doesn't reflect the types of objects you'd like to expose on the subgraph? Do you need to write your resolvers in a microservice on top of the DB and then federate it? Or is there anything else on the table? Can Hasura provide an abstraction layer over the top of the persistence layer?
Yeah, I think I know the answer to this. Sandeep, do you want to take a guess? Well, while you're thinking about that, so you have several different interrelated options that I think work together. One thing is, within the database itself, if you have this ability, one can transform a data model using database views. Okay, that's table stakes. But obviously, there are many settings where this can't be done. Hasura does have some options for customizing. You can curate the API that you develop. So for instance, just as a simple matter, if you want to perform transformations over the fields, the field names, the types in your GraphQL schema, as you track these tables, that can be done right within Hasura metadata. Right here, we see there's this option for custom GraphQL root fields. So that's the second option. Third, Sandeep, do you want to say something about logical models and native queries? That is another option.
Yes, you can. That is, I guess that is an extension of views, right? You don't need to, for example, if I don't have access to the underlying database, I cannot create views. Then what you can do in databases where this is supported is that you can write a SQL query or the definition of the view and define it as a logical model, and Hasura will kind of operate on top of that as a data source. So in effect, pretty much the same thing that you do with views, but in a more dynamic way without you requiring any access to the underlying database. So that's one way to kind of work around a database schema that is not quite what you want in terms of the shape and form of types, right? Yeah, that is logical models.
Yep. Logical models. So we see the UI here. So you define logical models, and then associated with those logical models, let's go back. Data. Here we go. I was just there. But as Sandeep mentioned, you're defining, essentially, Hasura has templating within it, so you can define something like views right within Hasura. So that's one. Here we go. Native queries right down here. Create new native query, and it's within this native query statement that one would write out the template for the query that you're interested in. If for some reason you don't have the ability, or it's not set up so that one can develop the views within your data model directly, and maybe you're working with a database that doesn't support these, then you can do it right within Hasura.
But I guess, David, at some level, if you don't want to do views, or if it's a fancy new database that has just started supporting and you don't have logical models, then or if it's, let's say, a set of APIs, like Hasura can also kind of generate a GraphQL API on a set of REST APIs which have an open API specification.
Yep.
Which is again, the important thing to note is that open API specification is like a database schema of sorts, and Hasura can read that and generate a GraphQL API on top of it. But if you can't change the underlying REST APIs, you let's assume for the sake of the argument that you can't, then there's only so much that any tool can do in terms of reading it and being able to customize on top of that, right? So that when you run into this constraint is when you probably need to write some intermediate microservices or some code to kind of reflect exactly the kind of types that you're interested in.
Possibly, Sandeep, it's what I like to call the 80-20 rule. Maybe 80% of the time you can get there. So if you're bringing in microservices as a data source with Hasura, it's quite likely that you will be using another affordance within Hasura, which is called actions. And within actions, there are declarative ways to transform both the input and the output. We have request transform, payload transform, response transforms. So, with a little luck, maybe 80% of the time, if you need to do you can get to the transformation that you seek declaratively with these affordances. Maybe 20% of the time you have to write that middleware code that you were just describing.
Yeah, that makes sense, and especially with the request and response transformation, I get a lot of degrees of freedom to play with the underlying source and define a custom type that can be serviced by the underlying source. So that does make sense. Perhaps I hope that answers your question. Happy to take any follow-up questions. Um, David, there's another question in the regular chat. About how does Hasura deal with types with the same name in different schemas? I'm sensing namespace.
That's right. So we go back to data, let's say for the account table that we have tracked, we modify it the way that if we start to adjust, we do some curation. We can say that this account type is, where is it? There should be a namespace option.
I think if you scroll to the top, yeah, these are all ways to kind of customize the name. But I think at the top of the table, you can add a namespace, I think, right next to the table name, I believe.
Here somewhere. Believe me, it's in here. But you can set up namespacing for track tables.
A table and also for a source. So you can do this at the source level itself. When you add a new data source, you can add a namespace, and you can also get a namespace.
Routing, advanced settings, GraphQL customization for the source. Here we go. Good point. So for this whole source, in this case, it's it's the subgraph, which I've said is associated with fulfillment. So why don't I just say that this is in the fulfillment namespace. And then we go back to our API. And now there is a fulfillment top level field, and all of the top level fields under query, which had been top level fields, they're now stuffed down into this fulfillment namespace. So that's one way to approach similarly named fields or types being brought in from different data sources.
You can also use aliasing, I think, at the table level, at the field level. You can choose to alias fields to avoid any kind of conflict.
That's right.
David, we have another question from Alan. Is it possible to add an extra layer for filtering based on some business logic using proprietary artifacts, assuming that's a jar file on top of the underlying data source, whether that's a DB integration or a microservice call?
Yeah, so probably like a good way to do some additional filtering. If this is a really good question. So one may already have existing filtering logic or business logic that you want to reuse. One way to do this is again through actions. So if you can set up provide this business logic that you have as an API, then Hasura can call out to that. That is one way, and that's probably the bread and butter way of adding additional filtering. But we can there are ways of solutioning some other options as well. But that's probably the key piece is actions is it's a powerful way for Hasura to access custom business logic, data validation, enrichment, transformations, and fold those right within your graph. But that does illustrate. So again, when one is building these subgraphs, we've said that maybe will involve maybe 80% of the effort, and that will be because it includes these activities like business logic, authorization, caching, security, and for the sake of business logic, again, the affordances we have are actions for like one way to think about this is it's like synchronous business logic. It's good for input validation, data transformation. We also have this events tab, which I haven't really had much opportunity to address, but this is another powerful feature within Hasura, which is asynchronous. As data update operations are occurring within the database through any mechanism, it doesn't have to be through Hasura. Any DML, any updates that are occurring in the database, inserts, updates, will be recorded by triggers that Hasura installs. Events will be recorded, and then Hasura has a whole event processing subsystem where we'll asynchronously process those events. And this is a good way for if you think of one category of your business logic as exhibiting side effects, right? Some operation has been performed in the database, and you want to ship a T-shirt or update a machine learning model or perform some billing operation. This is a good place for that to be done.
David, we have a couple of other questions as well. So I think Paris had a follow-up question, which I wanted to get to anyway, about exporting Hasura's config for version control and to facilitate deploying multiple versions of a given subgraph. Paris, yes, that is indeed the case. Everything that David kind of went through here using the UI. In the background, there's a config file being built and stored in a metadata DB. We insist that you version control this. This is the source of truth. The entire state of your GraphQL API it can be captured through this configuration. It's YAML or JSON based on your preference, and you version control this. You know the rest of the story. So you can bring up a replica of your API or different versions based on your changes. You can test them, and you can have code being promoted to various branches or commits and so on. So that's exactly how Hasura's configuration works.
That's right. Hasura's, as Sandeep mentioned, what you're authoring, we've said that you're still writing code for things like business logic, but for many of these other services, Hasura offers a declarative approach to developing your data model. And what are you declaring? What is the output? The output is, it's not code, but it's metadata. So where is the metadata? Well, the metadata it's in memory in Hasura. It's guiding all of the operations that you're seeing. But there are facilities within Hasura to reify that metadata onto disk as JSON or YAML. We have tools for doing this and we have other webinars, and we will be presenting other webinars on CI/CD and development workflows for enrolling this in a full-fledged software development lifecycle.
All right, and that brings us to the next question. Does Hasura connect to Neo4j databases, specifically Aura?
Hasura has for its database connectivity or for its data connectivity, we are modern, like the most current versions of Hasura. We have adopted a modular or a component approach where the actual data connectivity functionality is encapsulated within what components that we call connectors, so that they're no longer coded in core in Hasura. And that means that connectors, it's a bit of middleware. It's like a driver, right? It handles the low-level connectivity to a data source and then presents an API that Hasura works with in a uniform way. Hasura, we are writing lots of connectors. We are shipping connectors for different data sources. This is how we are offering support for Snowflake and Oracle and ClickHouse. And we are, again, connectors can be written in any language, so they can also be provided by the community, but Hasura will be shipping first-class connectors for a number of data sources, including Neo4j. Sandeep, do you know what the status of that is? I don't know if it's if
I think
it's,
it's on the roadmap, but
yeah,
relatively lower because Neo4j already exposes a GraphQL API by default. It has a REST API interface as well. So a lot of users in the community who use Neo4j, they've kind of managed to again leverage actions or remote schemas because of these kind of APIs being available on top of Neo4j. But that's kind of where our support for Neo4j is currently. We could build a connector, or we could use the built-in GraphQL API or the REST APIs on top of Neo4j. That's kind of where it is.
that's right. And that actually highlights another worthwhile point to address is, again, when you're writing code, what are some of the services that you're often trying to provide with code? Authorization, business logic. Another one is data integration. And, so being batteries included and covering all of the bases, Hasura has a story or has stories for data integration. Actions, we've talked about that. Events is another way to exhibit side effects as a bit of data integration. And then remote schemas is another piece within Hasura that allows you to bring in other GraphQL data sources, establish relationships against those relationships, and then enroll those other GraphQL services in all of the other non-functional concerns that Hasura provides, like caching, security, authorization. And as Sandeep points out, if a data source, a database like Neo4j has a GraphQL API already, then it's pretty straightforward to just include it directly that way.
David, I think this is also a good segue into another question we have here about whether GraphQL Mesh is a separate third-party tool. What about Hasura's own router working as a federation layer? I can take a stab at answering this question. I think remote schemas, as you saw, is one way to kind of federate over a subgraph that Hasura generates, as you can see in the diagram on your screen, and another GraphQL service, something that you have authored yourself, or if it's a third-party API or another team's GraphQL API. So you can use Hasura to kind of federate over multiple GraphQL services using remote schema. You add the GraphQL service URL, Hasura does the introspection, and allows you to do relationship definition and all of the other things. Also provides a centralized authorization layer and all of those kind of production ready readiness goodies that David was talking about. There are ways to federate over REST APIs as well. So you can, in some sense, think of Hasura as a multi-protocol federation layer. But this is nothing new. You can kind of do this with some effort using, let's say, Apollo's router or gateway. You might need to add some directives and maybe tweak your GraphQL subgraphs a little bit. But you can do this using Apollo's router or gateway. And GraphQL Mesh is a third-party open source tool as well. Like David said, there's a team of developers called the Guild, and they build some open source GraphQL products and they offer services as well. And GraphQL Mesh is one such product that allows you to perform quote-unquote federation, which is, yeah.
Yeah.
I hope that answers the question. David, please. You want to add something?
Absolutely. So as Sandy pointed out, absolutely, one can use just Hasura alone as a gateway, federating over multiple subgraphs and providing that super graph or that one graph. We've done lots of talks and lots of webinars, and we have lots of demos and community calls on using Hasura in just this way. That's kind of why, just for something different, I thought today I would try, instead of using Hasura as the unifying gateway, why don't I use GraphQL Mesh? But all of these are options: GraphQL Mesh, Hasura, Apollo Federation. It's pretty straightforward to bring graphs together with these different tools. Again, often that seems to be, there's that 80-20 rule again, maybe 20% of the work. Most of the work is actually developing those subgraphs, in our experience.
Yeah. There's one more question from Alexander about BigQuery and using it with Hasura Community Edition. Alexander, I've just dropped a note in the chat. You can just use Docker and get started with it. I believe you can also do this on Hasura Cloud. You can use a free tier and connect it to a BigQuery instance. So that will get you started. And I think just like, I don't know if we covered this before or not, but everything that you see in the UI is configuration driven. You can do this programmatically. We actually have users in the community who offer Hasura as a white label data API platform to their own users. Right, so people bring their databases and get an API for free, and then people can provide this white label solution to their users. So it's entirely possible to run everything that we just saw in this webinar programmatically or through configuration. And I think there's one more question from Abhishek that's pending. What kind of application should Hasura be used for? Anything, everything, even applications you haven't thought of yet. You can use Hasura in any context where you need APIs on data sources that it supports. And I guess that's the central premise of this webinar, which is if you want to build those applications out, if you want to support the front ends using APIs and you want to do that quickly, you should consider using Hasura, if not outright use it.
That's right. Anywhere where you have microservices, you might think of going with GraphQL. Subgraphs are microservices, and you can use Hasura to build those and ship. If you want to ship faster, Hasura is a good choice.
There you go. There you go. All right. I think David, I'm going to post your link to everybody as well. David does a very good job of documenting his demos in a GitHub repository. Lots of folders that you can find in the link that I just shared. And with that, I think we've come to the end of the webinar. We're also almost at the top of the hour. Lovely chatting with you folks. I think the interesting thing is that federation is a fairly dense topic. I mean, it's 20% of work, but there's a lot of things that you will need to factor in, especially if you're trying to roll out federation across multiple teams and so on in your organization, around who owns which part of federation, how do you independently deploy your changes, and how do you get some kind of automated validation whether your changes are breaking something. So all of the microservices integration problems in the GraphQL ecosystem is what you'll need to, in a sense, consider when thinking about GraphQL federation. So lots more to talk about. We'll be back with more, and we'll also kind of take this demo through to its logical conclusion. We'll try and do a version with Apollo federation as well, and also do the hierarchical nested graph stuff with GraphQL Mesh and maybe even Hasura as well. So lots more to discuss. So we'll see you soon.
All right. Thanks, folks.